Alright, so welcome to the third video about our text-based adventure game. We've previously gone over our design, and then we made the first iteration of our game, just the skateboard level in our metaphor. And now we're going to add in another major feature, and this will bring us up somewhere close to being a bicycle level kind of game. The major feature we're going to focus on adding here is the ability to move between different locations in our world map. There are various ways we could approach this, all of which are equally valid that have different trade-offs in terms of code complexity and code length and efficiency and various other factors. I'm going to go ahead with the one that I found most natural to set up and write. You may find a different one. There are various great strategies using data structures like lists and dictionaries, which we haven't really talked about, but are a totally valid thing to use. There are very straightforward methods using a lot of if statements. I'm going to use a few different things, a few different ideas that I think bring together and make a fairly effective way of handling this. So in our game, we've got several locations that you can go between. If you look at our transition diagram, we have our home that can let you go to the forest or the town or the winding way, and the town can go to the chapel or back to the home or to the castle. The chapel can only let you go to the town. So we've got several different locations that we can go between. In our code, a few functions cover the ability to handle travel. So in general, we have some sense that we've got to render our current location on the screen. We have to render the options available to the player for where they can go. We have to determine if the user has typed in a valid location that we can go to, and then we have to take the user to that location. So we've really got three functions that we have to be seriously concerned with. There are many other functions that might come in play here. You might have it might have certain things happening on the clock tick in different locations. You could have the world is good checking to make sure that the current location is a valid one. So there's more that can be done, but we're going to stick with the basics just for transitioning users from location to location. So we'll start off with our render. We have some sense that we want to print out the player's current location. We're going to use a lot of helper methods when we're doing this stuff. We're going to take advantage of various helper methods to try and organize our code. So when we call render, we're going to start off with a blank message, and we'll end up returning some modified version of that. Now, down the road, we'll do things like render the user's inventory and render the user's possible destinations and render their we'll say their abilities, or render their status, we can say, and various other opportunities that we can take advantage of there. But for now, we're going to stick with just rendering the user's location. We're going to keep it simple and focus on one thing at a time. The idea being that our render function is responsible only for doing the concatenation, the combination of all these individual render calls. And that sort of organizes our code, breaks up the problem a little bit more. Now we're focusing on render location, which would be relatively straightforward. This is a method that consumes nothing. It consumes, let me just make sure of that. Yeah, it consumes nothing. We'll use the current state. It creates a string representing a message to the user about the current location in the world. So this will be relatively straightforward. It returns a string, the message to display. Okay, so we have a field inside of the player that allows us to render the player's current location. And we'll take advantage of that to save ourselves some code. So our render function is basically going to be just a matter of returning you are in plus the the player's location. And then we'll add in a period and a new line character. So you are in the home or wherever. And we could do various other things here. We could make these more descriptive. If we wanted to, for instance, we could, instead of this approach, do something different, return a different string for each possible location. So if the player's location is equal to home, we could return something like you are at home. And that's a kind of a nicer phrasing. Instead of you are in home, you are at home. And then we want to do that for each of the different locations. So if you're in the forest, you can return you are in a densely wooded forest. And we can keep going. We'll give only a few locations. Our goal right now is not to capture necessarily the entire transition diagram and all the states. We'll just focus on the home, the forest, the town, and the winding way. So we'll have the town as another option. You are in a happy, well-populated town. And the last location that we'll try and cover for now is the winding way. You are on a winding path. So we're only covering 4 of these locations. And when we call our render location function inside of our render, we'll be able to see a string. So now we can go back down to our unit test and update it. Instead of printing the current world, we will instead print out, we expect it to print out, you are at home. And we'll need to make sure that we put a new line after the render location. Otherwise, things will not end up on separate lines. So at this point in time, now that we're going to focus on, we'll do one more run of the game where we actually play it. Uh-oh, we have a list error. We have some kind of assertion error. And that's because our render function did not produce the right result. I think I dropped the new line. Let me just double check. Yes, okay, great. I just forgot my new line. Got to remember to always have those in there appropriately. So, it's now having me play the game, and it says I'm at home. We don't have any other areas I can go to yet, so I can't really explore anything else. I'll just leave the game. And at this point in time, I'm going to go down. I'm going to actually comment out my my main function call. I'm not allowed to modify the engine, but I am allowed to modify the main area. Sorry, the if name main section. And I'm going to rely only on my unit tests to try out the game. I'm going to stick to them with the idea that this will be more convenient than having to actually try out the game each time. It's a good design strategy, it's a good development strategy to be building your unit tests as you go. And rather than relying on running the game each time and playing it out, which is A, cumbersome, and B, error-prone, you can have your reliable unit tests. And you need to unit test all of your code by the time you're done anyway, so why not do it as you go and get the benefits? And when we're a bit farther with the project, we'll talk about code coverage and how we can measure that visually and find out what parts of our code are not being unit tested right now. But let's go back right now and talk about our render method. So we have the ability to render out our current location, and we have a way of printing a nice little message about where we're at. We also need to make the user aware of the possible locations they can go. For this one, we're going to take advantage of a helper function. We're going to create a function called getDestinations. And this will be kind of similar in structure to our render location, getDestinations. It once again uses the user's current state, determines the available locations the user can travel to. And that consumes nothing, but returns a list of strings indicating possible locations for the user to travel to. Okay, so we're going to use the same structure we had before. We have a player's location, and we'll test it in order to determine what they can return. And there are various ways to structure this. So if we had non-mutually exclusive areas, we might want to build up a list by repeatedly appending options and then return one list at the end. In the same way that rather than our render returning a single string, it's building up a string incrementally, one step at a time. So there's two sort of different paradigms here of building something up incrementally and returning the final product, or just directly returning a string or a list, as it were. We're going to go with the latter approach. We're currently in the home. If you're home, then according to the diagram, you are able to go to the forest, or the town, or the winding way. So we'll say forest, town, or winding way. And if you're in the forest, you can only go back to the home. And if you're in the town, you can only go to home. And if you're in the winding way, you can only go back home. So it's a pretty limited world map at this point. And as we make more sophisticated additions to the game, we'll go back and expand this list based on our transition diagram. We'll add in the chapel, bedroom, the castle, the wilds, and the cave. But for now, we have our get destinations. We're not going to use get destinations directly inside of render. We're going to use get destinations in a few different places, but we're not going to use it directly in the render. My vision here, and this comes from some experience of having built large projects before, is that I will only be writing render functions inside my main render function. This is similar to what we did in the other projects. You know, we had your render rocket and render fires, and you tried to only call those render functions within the main render. So we'll render our location, and then we'll render our options that are available to us. So this will be on a separate line from the other one, and it now behooves us to write a function called render options. Consumes nothing. Produces a string, and as this is just a render function, creates a string representing the options for our player to choose from. And we can also put in some, we'll get to that in a second. Let's finish the doc string. Returns a string indicating the message to the user. A little bit redundant to the purpose statement, but it's okay. Okay, so we're going to start off with a message. Let's see, we need to print out something indicating about what you can do. How about we say that they can, or rather you can, :/n, so new line after that. At this point in time, we can get the list of options available to the player, so the possible destinations, via our self.getDestinations. It doesn't consume anything, produces a list of strings. Now, we've learned about for loops briefly. We can iterate through each of the destinations in the list of destinations, each of these lists of strings, and concatenate, add to our message with that destination. We'll put a couple spaces between it, and we'll write the words go to destination, new line, and then return our message. So we have a simple for loop here. It's just combining all of the strings individually with the go to before them. So now, when we call render options, it will use get destinations to figure out what destinations are available for our current location. At this point in time, we've got to go update our unit test. And this is where things get slightly more interesting, because now we have a longer multi-line string. And you could just keep adding things onto the end here. You can, and then keep going and going, trying to figure out, like, okay, well, I guess the next thing is you can go to here. That's fine, but it can kind of get cumbersome, and it might stretch off the screen. This is a good opportunity for a triple-quoted string. So when a triple-quoted string, we have multi-lines. We're allowed to just actually put our text on a new line. And that allows us to more easily see the text, and we can write it more directly. Now, the three locations that we can go to are forest, town, and winding way. So let's quickly copy them down here, get them in the right order. We have the forest, and then a new line. We can go to the town, and then a new line. And we can go to the winding way. And I think there is a new line afterwards. So let's try running that. Oh, nope, I got my assertion wrong. I'm thinking it's that it didn't need a new line. No, I still got the assertion wrong. Let's just go check it over. You're at home. All right, let's try running our render and see what it currently produces. You're at home. You can go to forest, you can go to town, you can go to winding way. And you can see that there's 2 new lines at the end. So that's the problem here, is that we need 2 new lines, no white space there. And now that we've spotted out, now we've got it. Now we've got the world render going the right way, and we're passing our asserts. And it doesn't matter what location we're in. This code is smart. It's dynamic. It'll be able to handle different locations that we're currently at. It'll get the proper list of destinations and update it accordingly. And our render function is still pretty neat and clean. We render our locations, render our options. We could render some other stuff like our inventory or our status, and so on and so on. A lot of options that we can build on here. But with our render options handled, our render function handled, we want to start processing user input. So previously it was just if the user typed in win, lose, or quit. But now we need to handle these go-tos. So one model is we just say, well, if the user types in go to town, then that's good. That's a valid command. And if the user types in go to forest, then that's great too, and we return true. And otherwise, we just check to see whether they've typed in our win, lose, quit. Long term, we don't want to have the options of letting users win and lose. So we can get rid of them now. And we need to make sure that users are always able to quit. So we'll move up the command for quitting to be right near the beginning. If they type in quit, they immediately quit. Otherwise, we check to see if they typed in some other command. And if they type in literally anything else at all, it's not valid. Now, as we add in more locations, there's this headache that we've got to start processing all these different go-tos. We've got to go to town, go to forest, and there are various smart things we can do to simplify this. One such smart thing is generalizing this. So there's a method called starts with that checks to see if a string starts with another string. We could just check if the command string starts with goto. If it does, then we can instead check to see if it's a valid location. In other words, we will take the command, the juicy part of the command, the location portion, and determine if it's in our list of destinations. Now, when we're doing that, we need a way of extracting out the location that the user typed in. And there are various ways to do this too. We could try and split based on spaces and do some fancy checking there. But we can also just observe that our user is always going to type in these set of characters, go to space. We've learned about the idea of string slicing, so string subscripting. We can take advantage of that and the length function to extract out the interesting parts of the string. So this weird looking expression right here says take all the characters, so find the length of this string, go to space, which is 1, 2, 3, 4, 5, 6. Take those 6 characters, that's the starting index, and then grab everything after that from the command. And that represents the new location. If the user didn't type anything in here, then they wouldn't have anything in there. But if they did, it would be that would be the string. And then the problem is simplified greatly. We're just asking if the new location given is in the possible destinations from where we can go from here. So instead of having to write this big if-elif chain, we were sneaky, and we're just processing sort of the bulk of this series of commands, reusing our getDestinations function. And it might be a smart idea to convert this weird bit of code to some kind of helper function like parse location. So that consumes a command, and will write a function, parse location, consumes a given command, and returns the command. And there are various ways we could generalize this. We could try and keep this goto thing more general purpose. So we could put it as a parameter and prefix as a parameter. And now the code is a bit more co-located. The goto is right next to the goto, and if we decided we wanted to change the thing that user types, we don't have to modify the code in two different places. So this is me thinking ahead, trying to be strategic. It might be an premature optimization. I mean, if I don't think I'm going to change it, I might be adding a lot of code complexity for no reason. So for now, we'll keep it simple. We're just going to have our command that can be parsed for its location. And when we do that, it returns a location. If it's in the destinations, then it's valid. And that's great. So we have our get user input. Is input good? We want to handle our processing. We've gotten rid of our commands for winning and losing. That's no longer an option. We'll keep our command for quitting. And now we'll do something similar that we did for handling user input with process. If the command starts with goto, we assume that we're getting a location from a user. So we'll get the new location. We've already verified that the location is good, so we can just immediately assign it to our player location. And right there, this is all we needed to do in order to get the ability to transition the player. So in theory now, we can go down to our unit tests, and we can assert that they can type in the commands like, instead of winning, we can go to town. And when we process go to town, there's no direct production, no value produced, but we can assert that the world player location is now town, if everything went well. And we'll see if I manage to handle this. Oh, nope, I have an exception. The world is not done at the end of this, and that's true. I forgot to update the subsequent test. The world is not done at this point, and we'll comment that out. So let's try it again. Okay, now our tests are passing, which is great, which means that we can now go to towns and travel there. And we can add some more iterations of our game. Let's do another render call after we've ticked. After we've checked that the world is not done, we'll confirm that. So we're in town. We'll start even documenting and organizing our stuff. We're home. Let's go to town. We're in town, so we can assert that the render should say you are in a town. What's the exact message? You are in a happy, well-populated town. Let's take that and put it in here. You can only go back to your home. When we do that, we'll assert that the world is, let's see, the input is good when the user types in go to home, and world.process go to home. So we're essentially playing the game the way that the engine would, and asserting at that point that the location is updated to home. And tick for no reason, and then assert that the world is not done. And we'll see if it works. And it does! So we passed our assertions. We're able to now travel the world. Let's actually try this out. We've got this game going. Every now and then it's a good idea to actually do a functional test. So we've got unit tests which verify individual components, and a functional test is when you actually try out the game. So I'm currently at home. I can go to the forest, and when I'm in the forest I can go to home, and that brings me back. I can go to the town, and that takes me back to the town. I can then go home, and I can go to the winding way and try out that one, and then I can go home again. So I was able to go all over the map and it's not listed here, but I can also quit. Now, one thing that's particular here is I've currently got the game in such a way that it's case sensitive. So if I don't precisely match the expected spelling on these things and punctuation and everything else, I won't be able to have my commands accepted. I leave it as an exercise to you to make your game case insensitive using things like the lower method and the upper method. But for now, this represents a evolution of our game. We've added one new feature, and we are now capturing a lot more of the complexity of our original diagram. We're not done yet. We'd still have to add in more locations, and we don't have our special ones, but we've certainly progressed from skateboard to something more approximating a bicycle.